Hi, it's Gadget UK here again, back for part 8 of the GBA 1000. It's a series that never ends. We are near the end though. I think the next part will be the last part. So, the gender change stuff, it's worth talking about that at the start here. So in the previous part we had loads of stress with the parallel and serial port. The gender was wrong on the Amiga 1000 and George, in his infinite wisdom, decided to replicate that exactly, the exact pin out on the GBA 1000. I was not aware of it. I've never come across the 1000 before. I was not aware of that. So you need a gender changer. In other words, you know, this is a 9-pin version. I'm waiting for the larger one for the serial port. You saw me test the parallel port in the previous part. That works. The bottom line with these though is, you know, it's obviously it's male to male, but you can see it flips the orientation. So if you look at that, this one's upside down. So you think it'd be up here somewhere, but it's not. That's not how it works. So it's like the pins just go straight across even though the gender changes. And then so you end up with a completely different mapping, if you see what I mean. It's like, it does get confusing. It's going to be up there, look. Yeah, so the pins do just go straight across pretty much, but they're transposed because it's the other way around. It can get a bit of a head masher trying to understand how those work. But the bottom line is, you know, we're plugging it into this one here, into a female port, and it gives us male pins. That's the thing, really. So yeah, the original design on the 1000 was balked. Next point to cover, and this will be revisited in the next part. I'll show you some footage from the previous part here. The two resistors that are next to the main crystal, yeah, the one that we've got 50 megahertz crystal in there at the moment. Making sense of the, you know, divide by 2. When the resistor's in the bottom position, it divides the clock speed by 2 using the AC74 on the other side. And that clock doesn't just go to the FPU, as we worked on the previous part, it goes to the CPU socket too. So if you divide the clock by 2, your CPU and your FPU run half the speed. And as we found, you don't get any RAM at all when you run at 25 megahertz. So in other words, there's a time dependency limitation on the way that the logic has been implemented that means you need to be around the 50 megahertz mark. As you'll see in the next part, I tested a 40 megahertz crystal as well, and it does work at 40 and the RAM works at 40, but as soon as you go below 40 you get no RAM. The bottom line is that divide by 2 was to allow you to fit one of these, 100 megahertz crystal. And you may be thinking, but why would you want to do that? Why would you want to fit a 100, divide it by 2 to get 50 again? And George worked out it's something to do with duty cycle. The duty cycle, and again this will be covered in the next video, the duty cycle is 50-50 when you use this 100 megahertz crystal with the AC74 on the underside. And as a result, it just runs a lot more stable and you should be able to get the exact 50 megahertz. Now I've got a 50 megahertz crystal in there at the moment. Seems alright. Will this fix the IDE issue? I don't know. Will it give me any more stability? I mean, I'll be honest, it's rock solid as things stand. I don't know. I don't really know what the benefit would be, but we'll come back to those in the next part. I had to rework one of these sockets. Can you see? It's shattered off at the back there. That was in this position here. And I came to just try and get Gary out, and I put a screwdriver under there, just leave it gently. Smashed off. Big piece smashed off it there. And yeah, pins, you know, are all bent over and stuff, big piece of it missing. The plastic on these is awful. Anyway, I'm just going to take the pins out of this and just put those in my spare pins in case I need to repin something or I get a missing pin. But yeah, I did have to swap that socket out. It's amazing how much rework I've had to do to this board as I've gone along. Right, more connectors have arrived. So this was before I became educated that apparently the connector that's on there is a bit weird. See, look, that's bigger. There's a difference here. At least I can't mix them up. These pins here go diagonal to the right, those will go diagonal to the left. So, you know, you've got to fit it backwards if you want to fit the profile right. So hopefully one of these will fit, and hopefully it's going to be correct in terms of the pin out there. I'm not going to worry about that too much, I don't think, because the worst case is if I get an actual 1000 keyboard, if I'm ever lucky enough to find one, then I could always put the right connector on if it's the wrong one. And then I've got this cable, which I think is going to fit in here. Yay. Can I get it out now? And then I'm going to stick a DIN, you know, DIN female on the end, so I can stick my 2000 keyboard in there and use that. And it sticks back quite far, so you know what, yeah, this is the better one. The other one would have fit too near there. And it goes, hang on, yeah, the diagonal's the wrong way around now. Oh no, it's not. Yeah, no it's not. The front pins are offset to the right, and here they're offset to the right. That one's going to fit. There we go, that's going to fit. So yeah, ordering the actual right part made sense, the DigiKey part number. These ones that kind of looked right, they've got the pin out the wrong way around. Yeah, and looking at it this way around, everything is lined up there, but the plastic bits here, let me show you, these look like they're going to be really tight to get through those holes, but everything does line up. If I get the pins in place, hang on. It's really difficult, there we go. So the pins are all lined up there, I can feel all 4 of them have gone through. It's just those plastic things. You can see here, everything lines up, but those plastic things, yeah, you've got to press them really blooming hard by the looks of things. Yeah, I managed it there. That was hard to get on. I should have filmed that. It was incredible amount of pressure, and it went clip really, really firmly. Look, you can see the connector indented on the thumb, but it's through. It's flat, I think. Yeah, it is now. I just push it backwards marginally. But those are through, those are holding, and all 4 points are there to solder. So, yeah, I can't believe it. Everything's going so well the last few days. After the trauma I had for a week or so, doing the, you know, all of the initial testing here, the stuff with the ports, the RAM issue, you know, we're left with only really one issue, which is the IDE's just a bit fluffy with that WHD load arguments, you know, invalid arguments. Don't know what that is at this stage. Still waiting for the 521. Can't really imagine that caused it. But it is an F device. Maybe there is a relationship to the selection logic on that, you know, IDE interface, that because it's not being selected quick enough on certain actions, a read or a write or something, that there's some sort of slight timing issue somewhere. So you know what, maybe the 521 will fix that. Anyway, let's just solder this on. The thing is, I'm not really going to know, have I done this right, until I get an Amiga 1000 keyboard. I mean, I could work it out by having a look at the actual official pinout of the 1000 keyboard. My point is, though, I don't have an actual Amiga 1000 keyboard. Anyway, the next thing is just to wire up a DIN to this, and then I can actually get a keyboard working properly with this without, you know, jerry-rigging like we did before with this. This was just a, you know, pragmatic bodge just to get us some keyboard functionality earlier. It's amazing they make cables in such short distances. You could pick, you know, the length, and I was like, how much, like, I don't know, 20 centimetres or something, or 30 centimetres. Yeah, 30 centimetres maybe that is, I think, isn't it? Anyway, that'll be long enough for an extension. And you can argue, and I may do it, is cut this in 2, because then you can make 2. Yeah, you can have 2. Yeah, well, that was lucky. I think I have one female. It's a grey one here, but you know what? The lead's white and everything. Does it really matter? And I think that's the right 5-pin. I'll test it on the 2000 keyboard first. But anyway, I'm going to chop this in the middle. Yeah, because it doesn't need to be long, does it? Sure, the bear really. And just wire that up. So nothing really much to show you. It's simple stuff, really. Yellow. I mean, there's a chance my cable doesn't work. Yellow is 5 volts. So it's black and yellow. I'll do the ground first. So the ground was pin 4 on the 2000 pin out. And they've got the numbers on the back, you know, you just got to look on the back and you'll see them printed on there. Now this has been used before. I'm repurposing this, it's got solder on it. So I'm going to need to just carefully just bend these little things marginally away from each other. Just because they're a bit close. Right, I just need to test it. I may need to swap my red and green. I have literally just gone with putting them on the pins I know are the date and clock. I don't know whether data is going to data, clock's going to clock. If it doesn't work, it doesn't work. You just swap them around. They both go to CIA, the same thing. So you've got no issues, you know, you're not going to cause a fault. You would do if you got, say, 5 volts or ground going to one of those pins, but I know that 5 volts and ground are correct the way I've wired it. Anyway, let's give it a try. Right, so powered on, you can see caps lock light has come on, goes off. So I just need to boot up and maybe get a command line or something. No, look, it's the wrong way around. So I'll be right back, swap data and clock around. Right, so by law of averages, it's got to be right second time. It has to be. No weird keys. QWERTYUIOP. Yay! We have a keyboard. Hang on, the return key on this keyboard's crap. It's one of these ones that's got a new hard membrane, and I think it just needs the PCB cleaning, ironically. So yeah, don't think those hard membranes are going to save all your problems. They are a bit hit and miss. Generally it works, it's just that return key. So I just need to just get this on, and I was wondering what this bit was here. I've never seen that, and it's because it's an inline one, you know, it goes like that there. The metal bit goes there, that's the ground point. And yeah, we just need to just get the wire through there and maybe push forward. Talked about this before with the other one, and crimp these together. I mean, it has been in use on something this before, because as I say, it's the solder was, you know, the solder points were all soldered. But yeah, that's going to be really nice. I can crimp that like that. It's a really good grip. That's nice and tight. It's not going to fall apart anytime soon. And I can just get this on there, I think, like that. There we go. For good measure, when you've been inside one of these before, or if you just assemble them for the first time and that's bent, you want to bend it up, because if it's not bent up, just marginally, when you slide this over, it won't hook into that little hole there. That should make a clip sort of thing now. Like that, that's it. And there's a pull back on it, it's stuck here. And with some of these like this, if they're cheap, you might want to just press it down so it's in line with the plastic, because otherwise it will just, you know, come off the hood. You can see I can pull that now and it's not coming off. So there we go, there's our Amiga 1000 adapter. The nice thing with that is, I think, because this has been designed for the pin out of the 1000, assuming that connector's right at the back, this should just work with an actual 1000 now. So I've got adapters for everything here. I've got power adapters, I've got keyboard adapters for every Amiga, pretty much. I don't think there's anything I'm missing. I've got one for the CD32, 4000, 2000, 1000, 3000, and yeah, power I'm talking about here, and the keyboard. Yeah, finally, my keyhole cleaning technique here. Yeah, right, so slightly crazy angle on the VGA there. Let's now test the keyboard. I want to launch Cabal, or Cabal. That needs a key press to start it, F1. So, yeah, it's not a very thorough test, is it? We just tested F1. This is that issue, look, with the IDE. See, there's no thing to launch it. You've got the slave, but then you close it, you open it again. Hang on. And not always. It's like a random, it's like 50% chance. I even wondered about a virus. Look, it's back. There we go. Why does it do that? And then you sometimes get the argument issue. We haven't done on this occasion. So I don't know what that is, what that issue is with the hard disk. But I mean, it works. This is the strange thing, is it's totally reliable at loading. Anyway, that seems to be working. So I think we've got to click the mouse. Do we? No, we press the fire button. And then I think it's F1 to start it. Well, you hit fire first. There we go, F1. Yay! F1 worked. It's incredible. It really is. I honestly didn't think I was going to be able to build this. Oh, auto fire is enabled on this at the moment, which is why I'm moving and not able to hold in the position. And if you're curious how Super Frog looks on this, as I always am when it comes to scandals on the Amiga, because of the interesting issues with the AJ Multifix and the 2000. Specifically, I think it was 244s, was it on there? Or 245s, I forget which. 244s, I think, on there. Yeah, no ring around the frog there. That looks perfect. Amazingly clear and sharp. Now I've got the keyboard connector sorted out for this. I'm going to connect that up, and I can do add mem at the command line after we switch it into, you know, 32-bit in terms of the addressing of the RAM. When I say 32-bit, I'm talking about the ZIII range. It's, you know, still addressed the same way, well, data bus wise, you know, it's not like got any performance benefit, and actually you'll see the opposite, it's slower. Yeah, so all I need to do is switch this jumper over there. That now moves this RAM into ZIII. Switch it on. I think, I don't think there's anything else. I always thought, well, initially I thought you had to solder a wire down here, but you don't do that. And if I connect the keyboard up, and once it's booted, I'll show you. yeah, and we'll need to reboot, because you'll see now, watch how much chip RAM we've got. We've got like none. Hang on, just give it a sec, it's catching up. Watch the memory at the top. I mean, you can see the IDE is slow already. Very slow. Look at that, 355k left, and we've got no fast mem. In theory though, I mean, I can alter the start sequences in a sec. In theory, I can just do the command here, and that should just add the RAM in, I think. Add mem, and we want to go from 1, 2, 4, 5 to, I can type 1, 9, 1, 2, 3, 4, 5. There we go. That should have added some fast RAM, I think. I assume it works in real time up here, hang on. Yeah, look, we've now got 8 mega fast RAM. Yeah, and I know this doesn't really prove very much because everything's running from slow RAM now, you know, from chip RAM rather, not slow RAM, but chip RAM is slower than fast RAM. I mean, what I can do though is just edit the start sequence, and I can just swap it back afterwards, because the thing is it won't boot when you've got add mem in the start sequence. If you then switch the jumper back, it fails to boot, you just get stuck on a black screen, which is really annoying. It'd be nice if add mem just went, there isn't any memory there, and just continue to work, but for whatever reason it doesn't. So if I do add start sequence, save it, reboots it. Yeah, I can't do a keyboard reset unfortunately. Yeah, so it's marginally faster at booting up because we've now got a bit of fast RAM, but not much. And I think you'll see the IDE performance will drop. Remember, we're at 2.7 meg at the moment. 2.7 meg per second we were. You can see now we've still got a big chunk of chip RAM disappeared, and that's because the add mem occurs after a point in the boot process where, you know, there's no fast memory. Do you see what I mean? It's like the fast memory gets there eventually, but it's a bit too late. In order, lots of things have already been loaded into chip RAM. So yeah, there's a few reasons why doing it this way I think is not good. If I go into drive speed first, I'll show that. DH0 speed. So we were at 2.7 meg per second. We're now down to 1.2 meg per second. This is the thing. So yeah, we've got 8 meg of RAM still in a different, you know, ZIII address range, and we can see that probably in memory here. Yeah, you can see there it starts at 120020 all the way up to 1. That's interesting. Why does it end at 1A? If you look at the start address there, it does. Upper bound. There must be something in that memory or in that area. I don't know. I don't get that, but it does say the end address is 19, followed by 5 Fs. Anyway, 32-bit local public, great. But it's not DMA. This is the thing. This is why the IDE is slower. And how do you avoid using, you know, lots of chip RAM as we have here? You know, look, these are all in chip RAM. This is the problem. This is why we've only got 1.2 meg of chip RAM free. Some things loaded into 32-bit log as it got further into the boot, but the initial stuff there, from, you know, kickstart and stuff, has gone into chip RAM. Anyway, we'll do a speed test as well, just to see how it comes out. I think it's going to be the same. Yeah, it's about the same, isn't it? 10.82. Yeah, and 2.23 there, I recognise that. So it's not really changed performance of anything at all there. But we've now got this issue that we don't have as much chip RAM, and the IDE is slow. So you've got to question, what's the point in that? Really? The only thing it does is free up the ZIII area, so that if I did have an RTG card now, I could stick that in there, and it wouldn't fight with the, you know, the 8 meg. The two could coexist. And ultimately that's what I'll end up having to do when I get the RTG card into this. But I think at that point I would coincide it with doing the upgrade to the 060, because if I fit the 060 board, I'll show you those things within this video. The 060 CPU card I think has got some additional RAM on board, maybe 32 or 64 meg. And that's going to be local ZIII, and then things would run really quick. The IDE still might be a bit slow, might not be any much faster than it is now. Anyway, so for the moment, I'm just going to switch that back. I'm just going to stick it back in the Zorro 2. Why would I want slower IDE, really? At the expense of, you know, gaining some Zorro address space back. So other than waiting for a gender changer for the serial port, I figured we'd best test the external floppy port as well. So I've got the Gotek connected here. There'll be a separate video on this. Got Nightmare selected there. Let's see if it'll boot from there. Woohoo! Nightmare started to load and then has died. Now the interesting thing is I saw this exact same behaviour when I tested on the 600. So there's something in the system it doesn't like, I don't know what. It's like the floppy version of it just doesn't work with this version of Kickstart. Or something, I don't know, it's bizarre. I know it works because I tested on a 500 and it was alright. Let's try Scramble, let's see if that'll work. Yeah, I don't have the joystick plugged in just now, but that has loaded fine. Right, the serial gender changer has turned up, gotta hope. This works. I always worry with these things because it's like what ends up, this pin 1 ends up 25, etc. They flip right round. So if we just plug that in, strap on, and as I say, those are just going to stay on there. Yeah, get these back on again. I'll test parallel as well. Even though we know that tested good before, you know, I think these are upside down, aren't they? Yeah, yeah. That's the thing. You know, if it was that way up, yeah, now it's not. Now it's that way up because of the gender changer. I hope that doesn't kill something, because the thing is, if you do get something wrong here, you can end up feeding one of the supply voltages into an I/O pin, which, well, in theory shouldn't do anything as long as it's not outputting. If something's outputting and you, I don't know, or if something's outputting and you feed ground to it, for example, well, you could kill the pin. Just finger touching those things there, it's booted from floppy, okay. Now let's see what's going on with serial and parallel now. Hang on, I've got a fault. So this is the thing, it's like I haven't entirely solved this, have I? Pin 22's balked there. Parallel. Well, we're down to 1 pin, aren't we? 1 pin being a problem, that's better than where we were. But what's wrong with 22? I don't know, it's enough to drive you nuts, isn't it? You could assume that maybe this loopback is making a bad connection, or the gender change is making a bad connection. Let's just try and pull that off. We'll have a look inside that in a minute. Let's just take this off. I'm going to have a look at the schematics. Maybe 22 is doing something different on this board versus the later machines. And the obvious one is just to take the dongle to pieces. In fact, we'll do that as well. Yeah, so if we have a look at the A500 schematics here, the page with the 2 CIAs on, if we look at the serial port and we go down to pin 22, ring, you can see you've got this EMI component here, but just look at this connection, it goes all the way up here. Through resistor, you've got a diode, a couple of other resistors around this area, and a transistor. Yeah, and ultimately the collector of that transistor is driven by PA2 there, isn't it? So we are lacking that, I think. And if we look at the Amiga 1000 service manual, and pin 22 is marked no connection. So it was not connected to the original 1000. And if we look at the GBA 1000 schematics, so there's the serial port, and pin 22 again is not going anywhere, is it? So it would seem we need to replicate the circuit here with the transistor in order to add the ring connection on the serial port. So the ring pin that's not working, I'm going to get it working. I'm going to put this in line with the later boards. I'm going to have this little board bodged underneath. It's one of these little SOP or SOT type adapters. You've got the different profiles and the different sides here. And if we look at it under the microscope here, you can see I soldered the transistor here. So we've got the base on this side here. Two rails are joined up there, it doesn't matter as long as it's not joined to this one over here. This is the emitter, that's a collector. So the collector is what goes to the port on the parallel port, one of the pins on there. It goes to like pin 4 and one of the CIAs, I think. And then the emitter is where the input hang on, comes. when I say the input. Hang on, oh, I'm confused now. Yeah, I need to check the wiring here. I'm not sure I've got the wiring right. This is ground over here. This is the base. So you have a diode with its anode on the ground, its cathode going to the base, and then you have a 10k resistor here, one side to ground. That doesn't go over here at this point, yeah. And the other side goes to the base again, yeah. So that's the diode dealt with and the resistor dealt with there. And then into that pin is where your input comes through a 2K7. I've got a 2K2, might need to swap that. I'll try and order one of those. So the input is going to come in here. I'm going to solder a wire on there. That's going to go to pin 22 on the serial port. And what's the other thing? Yeah, and then the other pin over here, I'm trying to think why I've got to go in there. Oh, that just goes to ground. That's just going to ground. Yeah, the emitter. So that's it. So we need an input here, a ground connection over here, and an output on either of these pins here, because I joined them. You know, it didn't fit because it's, you know, it's a triangular sort of shape, isn't it? These ones aligned with the pads perfectly. This one is in the middle. So anyway, I can pick either of those. Right, I'm choosing to stick it here because I've got a nice flat area and it's right next to the parallel port, and we've got ground there, so I just need one wire coming across the serial. So I'll stick it right up to this here. Hang on. There. Just try and get this straight as I can. It's going to be a bodge, it's a pragmatic bodge. But you can see it fits pretty flat, so I think that's going to fit inside the case okay. Should be enough clearance there. And then I just need to join ground up. So the ground I'm just going to take from this 7.4 series here, just need a wire from there to there, that's ground dealt with, and then I just need the input wire to here and the output. Or is it vice versa? It's the vice versa. Input from over here, soldered the point on it already there. It's the fourth one down on the bottom row here, pin 22 on the serial. Yeah, and this is why I measured it with the gender changer there to make sure I got the right pin. Yeah, it's there. So, yeah, it's annoying. So what I've done is I've stuck a ferrite on this PCB here. I'm just going to replicate the same thing, going through a ferrite and then in direct from the pin down here. So this pin, let's just double check it, is that one, isn't it? Yeah, it's that one, which is this one here. So then I can just put a wire from here up to the ferrite. I've just done that to save me putting another long wire all the way across the left hand side there. Which, yeah, might seem a bit crazy because we've got an additional ferrite in the path here, but it's not going to cause a problem. If anything, it's just a bit more filtering. This particular ferrite I've got here is, you know, default 0 ohm, so it's for all intents and purposes a straight path. So I mean, could it be better and smaller and tidier? Yeah, it could. I could have got a tiny adapter for that little component there, and yeah, it just could have been a lot smaller. So I'm going to go test it now. Let's connect it all back up. We could kill the CIA or something here if I've got something wrong. I've got that stuff on the bench again. It's like something's exploded. This is what happens pulling a china shop when I start trying to quickly resolve some issue that's stressing me out, and it's a small thing, but I like things to be as right as they can be. I will have to swap out these phonos at the back at some point because they're going to be a bit fluffy. You know, they're only held with 2 points, so like you bend it and it moves to the side, you know, so they're not going to last. Right, let's switch it on. I'm going to put the fingers on these CIAs here. And serial. Yeah, nothing going on fire. Oh god, I've got to try and get the mouse now. Right, let's do parallel first. Still working. Let's do serial. I think that's working. Yay! Successful bodge. Yeah, so totally successful there. I'm very pleased with that. Yeah, it looks bodgy, but you know what? The whole board is a bodge when you think about it. And we've obviously got the DTAC mod I did over here as well. And I've not noticed any IRQ issues since I did that. Non-maskable interrupts, you know, counter increasing in test kit. That stopped after doing that mod. So, yeah. Would you need to do it to every one of these? I don't know. Check yours. Go into test kit, run test kit, you know, different CIA tests in and out, going in and out the sound test, and then check on the CIA page there just to see if you've got any NMIs reported. And if you do, maybe consider the DTAC mod. If you're bothered about the ring signal, well, you can copy Crazy Me. And in addition to the mod, I've just done, like I say, a 10k pull-up probably needs to be added. I'm trying to think where. It's at the point where it goes to the, I think it's U4, the CIA over here, pin 4, and it's, sorry, not U4, pin 4 on it, you know, the one from the parallel port. Ironically, we're fixing the serial port, but you're hijacking the selection signal that comes from pin 13 on the parallel port. And that explains why, when I've tested these in the past and I've had a fault on one of the chips, that both ports come up as faulty, because there's a relationship between the two. You know, the CIA that you tend to think is just doing the parallel stuff does some serial stuff as well. Yeah, and as I was saying, there's also another pin on the parallel port that's missing a 10k pull-up as well. So if you wanted to get it technically 100% like for like with the later boards, you really would want to solder those two 10k pull-ups, but the fact the diagnostics passes is all I'm bothered about. If I later did something else parallel related and found I had an issue, you know, something wasn't working, a parallel device, that is the first thing I would look at, or even a serial device. I just think it's a simple thing to do this here, and lots of people, when they're testing something like this, you know, if I expire and someone picks this up, one of the things they may do is run test kit on it. And if you run test kit on it and it comes up with a failure somewhere, it may cause some alarm, even if you're never going to use that feature. Because this is the reality, isn't it? I can't even think of really many parallel and serial devices that we've come across on my channel. And that doesn't mean there won't be any though. I thought about doing some serial parallel stuff myself to utilise, because, well, it doesn't get utilised. Why not? Give it a bit of a blow like that. You can see I've now got it anchored there, and I'll just get a wee bit down here, so I'm just going to route it sort of slightly like that. Yeah, and I'll just get a bit here. Yeah, I faintly agree, that's not bad. That's not bad at all. It's fairly well routed there. Right, the 74F521s have arrived. Interesting thing is they came with a little gift. You know, you get these little things that says gift, and you get a little IC with it. And this looks like a Russian 555 or something. A Ukrainian maybe. It's got like a weird label on it, but it's got a Russian symbol there. And it came with two LEDs, which I guess are also a bit oddball. They're really short, but they are round. They're quite cool looking. I wonder what colour those are. Anyway, so yeah, I'm having to go putting those together and, I don't know, working out what the IC is. So 521. There is this question now: is this going to make any difference at all to the reliability with the IDE? You know, this flakiness where it doesn't show the, which one is it now? That one doesn't show the first file. I mean, it almost smells like a virus to me, the issue I'm getting, if I'm honest. Because why is it always the executable, the thing that, or not really executable, but the thing that runs the WHD load scripts, that's the file that always never appears in the list. So it's a wee bit odd. And then the other issue is when that happens, you run it and it goes invalid workbench arguments. You run it again, same thing. If you're unlucky, and then but more often than not, it will just run. And there are no issues loading things in games. So like you can leave time going round and round and round. So it's not like there's actually a read problem. It's actually like there's something at an OS level somewhere where just occasionally it's not able to find the executable in that folder or launch it, but everything else works. Explain that one. It's weird, isn't it? Anyway, so let's switch that on. 521 is in place. 688 has been removed. It's booting. I mean, I don't see how it would be faster. It did seem to boot faster, if I'm honest. That's the weird thing. so I don't know. Anyway, as Liv2 pointed out, an F is far faster than a HC. If we go to drives, DH0, I actually think that's quicker. I also can't tell, 2.7 meg, just feels a lot quicker. It's like when you click on these things here, this is instant. There was a slight delay before. Yeah, I guess only time will tell. If we quit out of that and actually go into a game though, because this is the thing, and it would always, get more noticeable as it gets warmer. And it's the only issue really that I've got that's outstanding with this machine. So for example, if we go to, I don't know, Cadaver, I like the music on that one. No, we've still got the same problem. So we've got the slave, where's Cadaver, the file? The file is not there. If we have a look at the actual attributes, you can see those are all like that. But if we go out and back in, still the same, out, back in. Look, now it's there. Explain that one. That kind of smells like a virus, doesn't it? It's the only one there that doesn't have the E on the end. But why does it do that? And then sometimes you launch it and it'll start, and other times you get that argument error, and it's launched this time. So, I don't know. Clearly we could have got away with using the 688 here. Yeah, and as you confirmed, that same IDE problem also exists with the Ripple. Now, it could be lied. This is the thing Liv2 did say. Is it the driver? Is it his driver that's got some issue? So I think we'll test the AT bus card next, but I've just proven I've got the same thing with the launching issue where it comes up saying, I don't know, invalid parameter or something, invalid something. And you go out and into the folder a number of times and the actual thing that launches the game isn't there. Everything else is, apart from that one file. It kind of smells like a virus, doesn't it? It's bizarre. It's like selective in terms of which file doesn't appear in the list. It's always the one you need to launch a WHD load game, which is bizarre, absolutely bizarre. If that is a bug, it's a crazy bug. Here we are with the AT bus card in, booted up okay, and I can tell I'm using a different SCSI driver here. You're not using Lide.device, you're using SCSI.device. Let's just do a speed test on that. Curious to see how fast that comes out. 2.7, almost as fast as Ripple with Lide. Are we going to be able to go in and out of game folders? Now, they cover something weird with this, where this compact flash card's set up, but all my compact flash cards are set up the same, if I'm honest. If I go back into Cadaver, and I managed to do this before, you see it's there now, that's the one. If I just widen this, you can see it's the one without the E on the end there. And yeah, just going in and out of it, you'd find that oh, it's disappeared, look, again, there we go. So we know it's nothing to do with Lide, the Lide IDE driver. It has gone from the list. Why has it gone from the list? I don't know. Now, if this machine has got a virus, this hard disk, the place it's come from is the GBA 1000 driver, the thing that programs the EEPROM, because there's nothing else that's been run on here before this problem started. There's nothing else installed. I haven't literally changed anything in months and months and months. And my other compact flash card's got all the same software on, and they're not having any of this behaviour. So, yeah, anyway, watch. If I close it, there's a 50-50, maybe less. Oh, it's back again. It's back again. How does that work? It's there again. I'm not sure if it relates to that unusual interrupt issue I was having. You know, we've got an extra resistor on DTAC now. That's got rid of the NMIs, but I don't know, there is some variation on this compared to every other Amiga I've got, where this weird problem occurs. So look, it's appearing every time now. But the problem gets worse as it warms up. That's the other thing. You know, when it's been on for half an hour, it's more or less 50-50, or even less than that. You might find you've got to go in and out about 10 times to actually get the executable there to appear. So yeah, if you've ever seen that on any Amiga, please explain. Please tell me what your thoughts are. Right, I'm a little bit premature, but I'm going to get this into the case here. And when I say premature, I'm still waiting for a couple of tantalums for the hybrids, one on each hybrid VCC rail, and the battery holder. But everything else we've got on there. So we covered quite a lot of bits and pieces in 2 exclusives on my Patreon and YouTube member only areas. So you can see these here broke off. You can see the one there snapped off. And on the previous part, I actually stuck a staple there, just melted it in place. I could file this down a little bit and put some epoxy there just to secure that. I might do that later. But I'm going to do the same over here because this one was half broken off as well in part 1. Just as a result of lifting the lid off, that was half hanging off and that one, the bits had fallen off it. But if I stuck some epoxy, and I will do that over there, file it down first, smooth it down to get rid of the charring off it, and then stick a little bit of epoxy over that. That should just help hold those metal staples in place. Yeah, so here we are with the board. This is going to be tight. And I may shorten some of these LED wires. We fixed this in a previous video. They were cut short, like not just a little bit short, like cut off so much there was no legs at all. On the power LED, why you would do that, I don't know. I did a little bit of cursing towards the place I got this from in the previous video. And that was one reason why I censored the company that I bought it from in part 1 of this, because I just didn't want them getting any flack. It might not have been them that did it. In any case, it was yeah, something that just really annoyed me. Now, because we've got the dongles on the back here, we've, well, got a bit of an issue. Let's just pull these 2 dongles off if we can get them off. Wire those on. And actually, it's pretty best to lift the back, put it through there like that, and then just lower the board, paying attention to the mouse and joystick ports over there, maybe. I don't know, this just feels so difficult. You know this when I covered the exclusives, that you can see here, you've got this drama scenario with these ports. Can you see? You see the ports are like right down here. So how would you get the PCB through that hole and that through there without bending those to the point where you feel like you're going to break them off? I don't know what Commodore were thinking when they designed this, I really don't. You might be able to go down at a shallow angle like that, maybe. I don't know, it just feels wrong. Please don't break. And I've got the support at the back one, which is in the wrong place, that's it. And then we've got support here, that's in the wrong place, there we go. Wow, this is tight. And one back here, that's not in the right place now, there we go, lower it. Oh, God, that was trauma. Sheer trauma getting round. So we've now got to try and get the back on. So it might need the board lifted up again here in order that I can get those things through. This port sticks out too far. Oh, that's so annoying. The plastic on that port sticks out too far. See, this is always the problem when you're sourcing replacement ports and things. This is just like a fraction too sticky outy. Yeah, so here it stands out a millimetre or 2 more than those things, and if we look at the size of that gap, I don't think that's big enough for that port. Just lift it up. No, it might be. It might just squeeze in. Yeah, that might just squeeze in. So if I carefully lift this, I tell you what, I've worked on some fiddly Amigas before. This goes hands down as the most annoying. I thought the 4000 was bad with its bay for the drives and things getting in the way. Yeah, you can see here, look, this doesn't want to go in because of the port. I might just squish it like that. Like, just about. It just about goes in there. It squeezes into that little hole. Yeah, if you soldered that slightly in the wrong place, you wouldn't have a good fit like that, but I've managed it. You know, it's not pushing this forward now, so that's just right. I guess I could get these here now just to skew those things, hopefully they'll fit. That's the parallel port one. That's the serial port one. Right, so let's just carefully rotate it around and inspect from the front. Yeah, everything looks alright there. That looks alright. So I've got a fan header. I haven't worked out where I'm connecting that yet. I haven't also worked out what I'm doing with the power supply. What I'm doing with the power switch, I don't know. Power switch cavity is over here. You know, the power supply would normally sit here with the power switch on the PSU, so we haven't even got a mount or anything to switch, you know, put a switch there. But I'll come up with something for that. I'll have a think about that. But right now I just want to get this board in, test the LEDs as well. So this then wants to come in here like this, I think. That's it. I'm just going to use the sellotape to hold that again, just to, yeah, give us a bit of support. And I guess at this stage now I can work out what I'm doing with these LEDs. So this one's going to be the floppy. This is the one where someone bodged a switch on the front, and then I've got the one that should be the hard disk now, the original floppy LED, I think, here. So I'm just going to get Molex connections onto that. And we've also got the power LED over here, again, that I fixed in the exclusive, so I'll get a Molex onto that. I'll get a Molex onto all three of these, you know, the hard disk one, sorry, the floppy disk one that I've chosen for floppy disk. Hang on a minute. Yeah, I was going to use this one for the hard disk, actually, the really long one. And yeah, it's extremely long, but I'm going to leave it that long in case I want to move it to a Zorro card or something at some point. Because you never know, I might decide not to use the onboard IDE at some point. Yeah, so these Molex pins, just going to use the microscope here, and I'm going to do my usual solder them on rather than crimp them. They're just going to be much more reliable, so we just need to just trim these to about the same size, because one's a bit longer than the other. And just trim down enough that I can actually solder on. If I pull that off, there we go, that's one. I need to be careful not to slide into the case when I do that. And I need to be careful not to damage the other end. I see that tape's not holding there. That's so annoying. Yeah, so just making sure the strands are twisted around each other as well as possible. And we'll just tin up these in advance here now, just to hold them nicely. You know, it'll just keep all the strands together. So I tend to get the ground in there like that, up to the point where it would be crimped normally. Oh, hang on. Yeah, it would be crimped onto that spade. I don't do that. I go for super long-term reliability by soldering. Oh, it's really difficult to, that's it, hold the wire, hold the solder at just the right angle. Oh god. Right, let's try and get the first one on. I'll try and get the solder down there. Like that. Wet finger. Yeah, try not to knock the screen. So that's one on there. You can see that soldered in there. There's no way that's ever coming out. But of course you can get it out there if you wanted to redo this. You know, you can easily redo it. And yeah, I'll crimp these together. Yeah, and then these things need crimping, and I tend to do them one at a time, sort of crimp. Hang on, you've got to get just the right angle here, tell me the right angle, to get it then in and down, like that, and then do the other side. There we go, that will do. So once I've checked the polarity, we can then simply push it into the thing here, making sure to get the right way up. Yeah, it'll go that way with a notch upwards like that, but I need to work out which one it needs to go into before we do that, so I'll just solder the other pin on. Yeah, and testing out the IDE LED. Hey, that's pretty good, isn't it? That's not bad. It's better than the awful switch that was there, and it came up pretty clean. There is the odd little nick around there, but yeah, that looks alright, I think. Let's just power cycle it again. Yeah, you saw that one flash there, another flash. It's looking at the floppy drive. Now bear in mind, I was going to use this one actually for the floppy LED, but I might just use this for the hard disk and put the floppy LED where the floppy LED was supposed to go. Well, it's not going to go where it's supposed to go, but use that for the floppy LED, which is, I believe that's what that was originally. Anyway, that's going to do the job. There's no direct connection to ground on either of those, so I had to just test to VCC and stuff. So, and I just tested it just by holding the connections on there a minute ago, just to see would it actually work if I had it the way around I was planning on putting them in, if you see what I mean. But if I just now connect those two things up, And just moving you back a little bit so you can hopefully see. So we've got our power LED. Yeah, so just wrapping things up here. Hopefully the next part will be the final part. I thought I'd just cover a couple of these boards here. So we've got here the RTG card. I want to get this built at some point, so this will be another video, hopefully all in one video of its own after we finish the actual main build. So yeah, it's got the Zorro connector here, designed to just go that way up. It's going to go into that one Zorro slot in the middle of the board like that. I think you've got 2 megabytes of RAM here. So that's going to eat into the Zorro 2 range. So this is where you then need to consider moving that RAM back into the 32-bit range. You're going to get a slower IDE. But we're going to have this additional 2 meg, so we're going to have the 8 meg on board of Zorro 3, and this would be 2 meg of Zorro 2. But then I'm thinking I'd like to try and add 4 meg of maybe a Lift 2 card. They've got to go faster. What I'm not sure about, because they've got one Zorro slot, I'm not sure that that's technically possible, because I think there's only the selection logic for the one slot. It's just a question of, well, maybe, I don't know, it might work. I don't know, it's about DMA and stuff as well, isn't it? But it's the auto config side of things. If you've not got slot selection logic, the auto config chain isn't going to work properly. I might be able to bodge something. Like, I was thinking about putting another a socket on top of this that faces that way, and then in theory I could stick Live 2's card in there, and then it might just be a case of trying to bodge the auto config some way so that both things could be detected, and 4 meg of Live 2's card might work in the Zorro 2 range, and then we'd have, you know, 4 meg, 2 meg and 8 meg of Zorro 3 on the motherboard. That would work. But as you'll see here, there's also a 32 megabyte board that fits into the 030 socket. It was thanks to Moxzor on the A1K forum. He sent me the Gerbers and things for that, and the Jeds and things, so I can build that. And it could be quite hard trying to source those lattice chips, but we might come and have a look at that in another video. And then we've also got, as I mentioned earlier, the 060 card. So, you know, you could remove that 32 meg RAM board, remove the 030, and then this goes into the 030 socket. You know, you have pins coming out here where the 030 would be, and then somehow, I don't know which way around it goes, presumed that way actually, and this fits underneath the floppy drive maybe. But yeah, there's some clearance issues, isn't there, with an 060? You get, you know, your chip in there and your heatsink, it might not fit under the drive. And again, this has more RAM. I think this has 32 meg of RAM on here. So, I don't know, I might build that at some point, and I've got some of the files for this, I think, in the Gerbers and things, but I mean, there's a lot of components to go on that. That's going to be a complicated build. And then, in addition, we've got this little riser here. Yeah, I think you solder it like that, so that can plug in, but you need some sort of, I think you have pins coming out of here, you know, and then the pins get soldered on either side like that, and that's how it goes into your slot. Obviously that way around. And then in addition to that, we've also got this, which again will be a video on its own. And again, through Moxzor, I managed to get the files I need for this. But it's a USB connection. Yeah, you have a USB port here, and this goes in the front slot. Yeah. And again, it's got the sideways or vertical, you know, the horizontal vertical, you know, socket thing here. So you can, I think the idea with this is on one side or the other, you stick like a Zorro slot, and then it goes like that onto the front. Whereas the original 1000 would have had, you know, a DRAM module there to give you the additional DRAM. I think the original 1000 didn't have 512k of chip RAM, did it? I think it was it 256k? I think it was quite low. It's a bit like the old Ataris. And we've got an Atari coming up from Parma, actually, so that'll be a future video. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. Every donation keeps the channel going. I cannot thank you enough for all of the support that you guys and gals provide me. The Ko-fi donations, the Patreon support, YouTube membership, all of those things are what are keeping the channel going. Advertising on YouTube, don't be under the illusion that people make millions of pounds on a channel of my size from advertising. You make peanuts. The advertising has just gone down and down and down on YouTube. Anyway, thanks for watching. I'll catch you in the next video.